Alright, so let's go back to our objectives of the week. We are going to deal in introduced. We are going to be why okay, so our objectives of the week is going to be introduced to pointers, arrays, pointers into arrays, references, introduced into structures, unions, and enumerations. So fast forward, what are pointers? Pointers are a variable that stores the address of another variable. Pointers can be used in any data type. Creating a pointer. A pointer can be declared in the same way as any other variable, but with an asterisk symbol. We have assigning address to pointers. The address of assigning address to pointers. Alright, so there seems to be a typo error here. So the address of operator determines the address of any variable in C++. So here is an example. We have differencing a pointer. The process of accessing value present at the memory address pointed by a pointer. And here is a displayed example. Differencing a pointer. So modifying a pointer address. A pointer can be modified to point another address of the same type, and here is a displayed example. Modifying a pointer address. Here also is a displayed example in C++ with Visual Studio Code. So we have data sizes of pointers. Equal data sizes for all pointers based on operating systems and computer CPU architecture. So you have the 8 bytes for 64 bits system, and you also have the 4 bytes for a 32 bits system. So we have the data sizes of pointers, and we also have special types of pointers. So we have the wild pointers, which contains random memory address that may or may not be valid. That's the int asterisk pointer. And we also have the null pointers. The null pointers points to no valid memory location but now. Also, it initializes a pointer that does not need a memory address pointed to. And we also have the int asterisk pointer, which is equal to now. We also have special types of pointers. We have the void pointers. It also points to a value with no particular type. We have the dangling pointers. The dangling pointers point to earlier valid address even though referenced memory address is erased. We also have the references. A reference works as an alias for an existing variable, providing an alternative name for it and also allowing you to work with the original data directly. We also have references versus pointers. So a pointer allows you to pass potential large amount of data around at a low cost. Instead of copying the data, we simply pass its address as a pointer value. So we also have creating references. So the and is used to create a reference. So an example can be t and ref, which is equal to var. So this is an example of creating a reference. Alright, so application of references. We have passing arguments. We also have returning references from functions, and then some properties of references. So you can access a reference with exactly the same syntax as the name of the object. A reference also refers to the object to which it was initialized, and there is no now reference. So we also have arrays. An array contains multiple objects of identical types stored sequentially in memory. Individual objects in array are called array elements. Array elements can be addressed using an index or a subscript. So defining an array, we have the syntax, we have the example, and then the data size. So the syntax is the type name or the size, and the example can be the float array, the float array, and also the data size can be the number of bytes of the data. So we also have index of arrays. Index specifies the position of elements in an array which starts from 0. The subscript operator is used to access individual elements. Elements in array ranges from 0 to infinity. Initializing of arrays. Initializing arrays refers to defining the elements it contains. A list containing the values of individual arrays elements is used to initialize the array. Example, int number. Then you input the number, any number of your choice. Initializing arrays takes a practical example of which we are going to do soon. And accessing arrays and elements, so we have accessing arrays elements refers to viewing individual arrays items such as the structure, and the example. So we also have the multi-dimensional arrays with columns and rows. We also have the two-dimensional arrays, which are the data type array name size 1 and size 2. We also have declaring 2D arrays. 2D arrays have rows and columns and can be visualized as table or a matrix. We also have declaring 3D arrays. So in the 3D arrays also have rows, columns, and then depths, and can also as well be visualized as table or matrix. We also have the struct. The struct or a structure is a sequence of elements or called members of habitual types used to create. It is also used to create user defined data types. Okay, so we have the structs examples. So this a code display of a struct. This another code display of a struct with a struct address, and then creating a struct variable. After creating a struct variable must also be created. So creating a struct variable has this code display of a struct. So the address is to display Tesano. So creating a struct variable with definition. A struct variable can be declared when with its definition. A, a struct variable can be declared with its definition. So creating a struct variable with definition has this also a code display. So we have to display the age. The address name is what the student, but we are asking the code display to display the age and gender of Julia. So accessing struct, a struct member can be accessed using a dots operator. Accessing structs can be used by using the dots operator. Assigning a struct member. A struct member can be assigned using the assignment operator, which is the equal to. So a struct member can be assigned using the assignment operator, which is the equal to sign. We have the assigning a struct member. So this is a bit code display of the assign member. We also have the union. A union is a struct that holds the value of just one of its elements at any one time. So creating of a union, we have a union just like other users defined data types have to be defined before we can use it. So creating a union is also having this code display, of which will be done in our next session. So creating a union variable. After creating a union variable must also be created. So this is also a bit code display of a union variable. So creating a union variable with definitions. A union variable can be declared when with its definition. Yeah, with its definition. We also have the accessing union. A union member can be accessed using the dots operator. Can be accessed using the dot operator. Assigning a union member. A union member can be assigned using the assignment operator, which is the equal to sign. All members share the same memory. Only one element can be stored a valued value. Accessing values through other variable may lead to undefined behavior. So what difference can be abstracted from structs and then union? The struct allocates the memory for each member variable sequentially. The size of a struct is the sum of sizes of its members, including padding for alignment. Members can be accessed independently at any time. It is also a struct is also used to group related data of different types. So we have the structs and union, and also the union deals in allocating memory only for the largest member variable. All members share the same memory allocation. The size of a union is the size of its largest member. Only one member can be active or hold a void value at a time. It is also used to save the memory when only one several member is needed at a time. We also have the enumeration. An enum or enumeration is a type with a set of named constants called enumerators. So an enum or enumeration is a type of set of named constants called enumerators. So it holds the enumerator holds a set of integer values specified by the user. The possible values are named and called enumerators. The two types of enumerations can be enum classes and plain enums. Enum class is also uses classes for defining enumerations. Defines an enumeration called color. Enumerators are red, green, and blue. We also have the plain enums. The plain enums can be unnamed. Unnamed plain enums are used when a set of integer constants are needed rather than a type of use of variable. So this is a bit code display of the unnamed plain enums. Thank you for your time.